All right. So thank you for coming, even though there's apparently a Debian thing on tonight and I guess some other stuff. Yeah, I mean, the whole point of this is that we're all working on different teams. We all have an approach to testing. And we don't really have a decent way of sharing that information. So it's good to kind of come to UDS, touch base, and talk about some of the things that we've been doing over the past 6 months that might be interesting to other people. I can't count the number of times I've explained PyFlakes to someone who had never encountered it before and was like, oh my god, this would have totally saved me 1,000 times over. So anytime we can have an opportunity to do something like that, I think helps us all. Right, so I'll actually start us off. So what I'm about to talk to you about, you should not do. This was very much a learning experience for me. Basically, in summary, use Juju. Don't write your own kind of nasty shell scripts based on top of Cloud in it, because you'll get bitten thousands and thousands and thousands of times. But I needed something quickly, and I didn't think I needed everything that came with Juju, and like any engineer, I decided to NIH something. So what I have here is so this past 6 months I've built a crash database for Ubuntu, and there are a number of different components to this, and I wanted to be able to, in addition to doing unit tests, do system level testing. So I wanted a framework in which I could basically launch the entirety of the crash database service and run a series of tests over that. But equally important, I wanted to be able to create the environment in the cloud as I was developing it, rather than just kind of throwing everything together on my local machine, because I wanted something quite close to what the canonical web ops team would be ultimately deploying, and that I could fire up when I needed to test changes rather than actually just cowboying something onto production. I don't know if you're familiar with Cloud-In or not, but it basically provides a means of when you spawn an instance doing a set of additional work. In this particular case, I'm just having it run a number of different commands. So I have it create a Cassandra instance, a Rabbit instance, retracer, and web server, and then glue it all together. And then I can just do one SSH forward, and I can then just have crashes come in and go all the way through to the database and be retraced and everything else. So I'll just kind of show you what it. No. So obviously I'm not going to have enough time to actually sit through all of this and have it set up. Fortunately, like any good chef, I have a complete running set of these things that I assure you I did all of like 15 minutes ago from that very same command. So if I get rid of all of my crash data, restart Whoopsie, which is our crash reporting daemon, and then I quite nastily start a program and segv it to drop a core dump. That's going to load and then blow up. And then I get a nice little crash dialog. Incidentally, since there aren't a ton of us here, and there's only a handful of presentations, I'm not going to be as strict as I was last time about going over time, especially as I'm probably already over time myself. But yeah, just for fun, we might shout at you anyway. Ignore that dialog, because it's a hideous bug that I need to fix. Right, so it's set the crash metadata up, and hopefully it's going to send the core dump as well. Every time I get on stage and do a presentation. So it hasn't said the core dump. I don't know why. And rather than stand here and debug it in front of you, just take my word that at some point it would end up in the database like that. And then down here, it would actually go through the process of retracing it. So that's that. Again, don't do something stupid like this. Use Juju. But I do think there's immense value in if you're building out a service, to actually build it as it will exist, and to have something there that you can constantly use, not just for system tests, but just continuous development with. that closely matches what you have in production. So thanks. If you guys who are giving presentations could just kind of slowly start forming a line, and then we'll make this a lot quicker. But whoever's next. Thanks.
Okay, so I'm James Page, and this is my colleague Adam Gandelman, and we both work in the Ubuntu server team. We're going to do this in 2 parts. I'm going to do a few slides about the work we've done in the last cycle on automating OpenStack testing on Ubuntu, which I did talk about last UDS as well. And then Adam's going to do a quick walkthrough of the lab setup we've got and how we're using it. So what did we set up to do for Precise? The overall objective was per commit testing of OpenStack on Precise on real hardware. We wanted to trigger this from upstream commits, so we were getting as close to upstream trunk as possible, tested as and when those changes were being made. We wanted to put it on hardware, and we wanted to test it as thoroughly as we could. And the graph at the bottom is the target topology that we have, which basically consists of 8 nodes in our base configuration, and we're going to be expanding that next release. How do we do it? With some servers, 12 Dell 1U pizza boxes, which had some basic power management support, so we could power them on and off remotely. For scheduling, we use Jenkins, which seems to be becoming more and more widespread on the Ubuntu project. And for our localized build process, we used a combination of sbuild and repro to publish a local archive of packages for use in the lab. For deployment, we used Juju, originally with Orchestra, as was in Oneric, but we've recently upgraded that to use Mars on Precise. And for actual testing, we use 2 upstream projects. We use the what's called the exercise scripts from a project called DevStack, which allows us to do a basic smoke test of OpenStack, and then a more thorough test suite called Tempest, which is getting a lot of adoption upstream and does quite a full, complete test of OpenStack. We had some glue to stick that all together, which we've called unimaginatively the OpenStack Ubuntu testing project, but that makes it all hang together. Results, well, we've got per commit builds of OpenStack Essex on Precise. We've almost got that set up for Quantal and the Folsom release as well. We're doing it every commit of Nova automatically on hardware, and we're testing it every day. Well, every day there's a commit anyway. This really resulted in early detection of both upstream bugs and packaging bugs. I think that's been probably our most significant contribution from this piece in terms of feedback to upstream. And it's really allowed us to develop the set of charms that support deploying OpenStack with Juju much more closely to the upstream changes as they've been made than we'd managed in previous releases. And we've also been able to do some other stuff that we didn't have as objectives, which was mainly pre-commit builds for stable releases of OpenStack as well. And we'll be using that for Essex on Precise and Folsom on Quantal once we release that as well. So a quick link in there if you want some more detail of exactly how this all works under the hood. And just one final slide, which is the credit. So this did involve quite a few people over about 6 months. So Tim, Brad, and Pete from the kernel and QA teams were really helpful in getting the lab up and running in Boston. Chuck and Adam and myself really set up the whole CI environment. Andreas for developing fence agents so we could turn on and off our servers properly. Davey for being a pain in the ass and making sure we got stuff done. And Larry for adminning it since it's gone in. So thanks very much. I'll pass you over to Adam now, and he'll give you a quick demo.
So, as James mentioned, we previously were using Orchestra to do all this hardware provisioning in a cloud-like way, but we've since upgraded to MAS, and here is our MAS cluster with all of this hardware registered in it. And then we have physical access to this stuff through a network KVM switch, which I just closed. But the main Jenkins dashboard looks something like this, and ignore the red dots, because since Essex OpenStack is on a cadence similar to ours, but they released 1 month before us, so that gives us 1 month to shake out upgrade bugs and things of that nature before we get precise out the door. So that kind of threw us for a loop, and we still have a lot of work to do to scale this out to support multiple versions of OpenStack on our current dev release as well as our stable release. So this is kind of in a state of flux right now, and we have had a session, or a bunch of sessions on what we're going to be doing with this in the future, but I can kick off a build right now. And what this is doing is using Juju to interact with Maz to deploy this really complex system over all of these nodes we have. And to give you an idea of what that actually looks like for anyone who's familiar with Juju, the build actually at the end ends up calling a number of Juju commands for anyone who's familiar with the tool to deploy the services and add relations and kind of connect the dots between the services. But rather than just doing that in a shell script in a really naive way, we wanted to be able to test different kinds of configurations with different flags set for each service among the different nodes, and to, in the long term, test a number of different ways of configuring OpenStack because there are so many. So we had to write a little deployment tool to be able to describe these configurations ahead of time, which is in the repository James mentioned. At the beginning of the deployment, you'll see it chooses nodes, and it assigns a Ubuntu release to it, which corresponds to a profile in the machine provisioner. And then it begins firing up nodes on the actual cluster, and these should be booting into a Debian installer eventually, the Ubuntu installer. We want a really quick provisioning of nodes instead of going through the whole process of installing a fresh node from scratch from the archive. We worked out a little bit of a hack where at the end of every provisioning, at the end of every installation phase, we take the root logical volume, move it to another location and snapshot that so that and rename the snapshot the root file system so that when it boots, it's booting from an LVM snapshot. And then if we want to do a quick recycle of all these machines from scratch, the following provisioning phase actually rotates that snapshot, the pristine one we took, or sorry, the original that we created the last time, puts it back. It does a number of hacky LVM tricks to basically eliminate the need for a fresh install and get our recycling provisioning phase down to, I don't know, 7 minutes from 20. And then once that fires off, it waits for a good state, the cluster's up and running, and then it pulls down these upstream test suites that configure the cloud to a usable state and starts exercising it through its EC2 APIs and its Nova APIs to make sure all the pieces are actually working together. And in the really naive tests, in the basic tests that we do, we're able to really discover bugs that no one else is really discovering, because I think, as far as I know, we're the only company out there, the only group out there actually testing this stuff on hardware. The upstream project does do gates on all the projects and a number of integration tests ahead of time, but it's all in virtual machines, and there's a lot of assumptions to be made about OpenStack when everything's running on the same node. So we split it up and do it in hardware on a real network, and so far we've shook out dozens of bugs that we've been fixing upstream and got to give them back to the project. So that's what we got, and if we had more time, we could watch the whole thing go. But
yeah, it's about 20 minutes start to finish. So.
Yep.
We could, but
that's it.
So anyway, so I'm Barry Warsaw, right? So I just wanted to show you some stuff about how you can maybe better package your Python libraries and applications so that you can enable the testing when you build your package. Because most upstreams do have some test suite, but very often, you know, as I'm packaging stuff or looking at stuff, I realize that the tests are never run while the package is built, and I think it's generally a good idea to do that. So, first of all, the URL, right, the Debian wiki, you can go to /python/library style guide. It has some best practices, at least as they exist today, for how to package up Python libraries, and there's a lot of good information in there. But specifically, if you look at these lines, let's see, these lines here, they show you how to get the tests to run when you build the package. So the first lines really define the versions of Python 2 and Python 3 that might be available to you. And then the next two lines, the %:, basically builds, it uses the helpers to build the Python 2 and Python 3 version using the DH-Python2 and DH-Python3 helpers. And then the if equal line basically will disable the tests if you set deb build options to no check, which a lot of people like to do sometimes. But generally that won't be set, so it will run the tests. And then the test Python %target is a wildcard that will get invoked for every version of Python that you're building your package for. And then the next line will run the setup.py.test. Let's see, I think I can't show you that exactly, but the idea is that that line may change depending on how that package's tests get run. So some packages run nose tests, some packages run whatever testing framework that they actually use. So you may have to adjust that. I was going to show you the setup.py that you can create to so that command will work, but since I don't have my laptop, I'll just tell you. If in your setup.py, if you are setup tools based, you can set test_suite. You know how in your setup.py you have a bunch of keys? Set test_suite to the Python dotted path to where your unit tests, the top of your unit tests are. And then that hooks into the setup.py.test. And I think it's a really useful way to run your tests. And the -VV just increases the verbosity. And then you can see you have to override DH-auto-test to actually invoke it for every Python that you're going to build. Pretty boring. Most of you probably know how to do it, but anyway, I just want to advertise that because as you're building packages, please try to go and enable the tests. It really helps to increase the quality of the packages. Anyway, that's it. Thanks. And thanks for...
Who's next?
So the reason why DH isn't doing that by default anyway, I think I've talked to the deb handler maintainer, and there's some interest in doing that, but right now it doesn't know about. He's not convinced that that's a standard way of doing it, so he hasn't added it to it. I know, I'm still trying.
What I want to talk about, and I guess I'll just talk about quickly, just because I think it's a neat concept, is we created, when we started a lot of the product strategy indicator work, a little utility called DBS Test Runner. And the idea of DBS Test Runner was to create a clean DBus session so we could actually do testing of DBus services, DBus the indicators, the DBus menu library all together. And it was kind of a nice little shell script. You could run things under it. It created a clean DBus session, and it's worked pretty well. And then we started looking at how we can do testing better and how we can do testing in a reportable fashion. And having a bunch of shell scripts, while it provides coverage, doesn't provide a lot of data about what happened. It doesn't provide a lot of introspection into what's being tested. And so we wanted to change things to be able to use more gtester or Google Test, specifically Google Test, but gtester is fine too. And so we said, well, how can we use DBS Test Runner? How can we get these results in a better way? And so what we did, 3 weeks ago? Yeah, 3 weeks ago, is we basically took DBus Test Runner and turned it inside out. And we said, hey, we need to be able to get into the internals of DBus Test Runner to be able to run these DBus sessions, to be able to run DBus tasks, and figure out what they're doing and be able to run against them directly. And so we created a small library called Leap DBus Test, which basically all it does is allows you to set up a custom DBus session for the process you're in, but also run other tasks and be able to coordinate them and introspect them and figure out what's going on so you can actually create a test suite that runs against those services. So we've got libdbus test as the DBus Test Runner. When we do a next release, we'll get that out. It'll be geometry introspectable, so you can do it for your Python tests, your Perl tests, your, I don't know, I'm sure there's a scheme plugin too, for all you scheme testers out there. And it's just an interesting library that allows you to test DBus services. So if you're doing something with DBus and you want to test it, I think we've now got a good way for you to do that. And I'd show you some code, but you can look at it in the launchpad.net/dbus-test-runner, and in the source code there's a libdbus test. Cool, thanks.
My name is James Hunt. I work in the Foundations team. I work on developing Upstart. This is just some random thoughts and information about how we test Upstart. Is that? That's a little bit too... Let's try that again. Can you actually read that? I should read that a bit bigger. Okay, so if you don't know, hope you do, but Upstart is the revolutionary init daemon written by Scott James Remnant. Contrary to popular propaganda, it is next gen. It's PID 1 on the system. It runs on every desktop, server, and cloud system. So I'm trying to read the text as well. I can't look at you at the same time. It crucially uses the NIH utility library, not invented here, written also by Scott. It's a very, very clever bit of software. It's written in C. It's kind of object-oriented C with garbage collection. Oh, and by the way, if Upstart ever crashes, you're in trouble. So I have a huge incentive to make sure it's tested well. We have a massive suite of tests with Upstart. I won't read all the figures out, but there you can see them on the screen. NIH itself also has, well, almost 3 times as many tests. What? How do I get rid of that? That won't disappear. You're not seeing that? Okay, cool. So every feature we put into Upstart has to be backed by tests. It does slow down development, but I think we'd all agree we'd rather have a reliable init system rather than one that just runs very fast and might crash occasionally. So there's a significant amount of testing that's performed by myself and other teams. Every single build of Upstart triggers the tests. Every test must pass, obviously. And every change is code reviewed. So this is the testing that I personally do before it gets anywhere near anybody else. Physical, virtual, LXC. I've now got an ARM device. That's been interesting for Quantal because, sorry, for Precise. We've had a few issues where customers have been using Ubuntu on ARM devices and they don't have init RAMFS. That's not a sort of a configuration we currently support for 32-bit, i386 AMD 64. But I'm now in a position where I can actually do this testing and catch some of these issues early. Oh yes, so I was finding that the cycle time for testing Upstart was pretty slow. Essentially, we've now got a little script. Oh, you're not going to see that. Darn. Let's move that over. Can we move that over? Oh, we can't. This worked so well before. Hold on a second. Essentially, when you can tell I'm a command line person. I don't really do GUIs very well. I can't actually see where the cursor is. Okay, so when I boot any of my VMs, let's try that. I'm going to hold it there, I think. When I boot my VMs, I get that rather than a desktop. So it's just a little menu. I can just select whichever version of Upstart I want to test with, or a shell. So it just gives me full control. I don't have to, I pre-configure grub. I can select whichever version I want, debug builds, and so on. Let's go back to there. Where's the window going? Okay. Why is it not reacting? Computer. Okay, this isn't going to work. Ah. It seems to be dead. Okay, that's helpful. Well, okay, essentially, I've got a couple of PPAs. I'd like to make more use of those for Quantal, so if anybody's interested in helping do early tests of Upstart, it'd be much appreciated. We've got other plans for Quantal in terms of testing, sort of scenario-based testing, system testing. One kind of interesting feature, which I wanted to show you, but I can't now, is there's a feature in NIH which basically allows us to display a message when a test is run. It just basically says, this test is run, and then eventually you get a pass or fail. With a very minor tweak, I've managed to make a change, a minimal change to the code base, such we can now conditionally run any test. And bearing in mind there are thousands, some of those tests are running using ptrace, which stops you from actually using GDB to debug those tests. So now I can actually conditionally disable or enable any one of those thousands of tests. That is therefore going to speed up the development, hopefully. And that's pretty much it for me. Thanks very much. Sorry about the problems.
So my name is Paul Larson, and I was going to do a talk on lava, but I'm thinking of changing my talk to suggest that our best possible way of finding bugs in the future is for all of us to do lightning talks. Anyway, so I'm working for Canonical, and I'm seconded to Lenaro right now, and we work on a test automation system we call Lava. So it's basically just got an extensible web front end. We have device management, and we do automated deployment to several different types of ARM development boards. And to some of you who may not have used ARM development boards before might not know, they're a little bit tricky. They're all a little bit different from one another. They don't normally support nice things like Pixie Boot. They don't have BIOS. So we've had to do some interesting hacks to get it to deploy to them. We support XML RPC APIs for our front end, and we also have command line tools that make use of those. And we have to not only test on Ubuntu-based Lenaro images, but Android-based images as well, which presents some interesting challenges also. So how do we use Lava? Our daily automated tests run on Lava, and that includes multiple different images, such as text-based images like our nano image, which is a really stripped-down image, as well as our developer image, as well as graphical images like our ALIP image and our Ubuntu desktop image, which includes both Unity 3D and Unity 2D on ARM hardware. We also have continuous integration testing of Android builds, and we also do continuous integration testing of several upstream kernel trees by basically building them and then injecting them into the hardware pack before building the image and deploying it on a board. We also do enablement tests on our platform, such as testing the devices themselves and the support for things like Wi-Fi and Bluetooth and all the various bits and pieces that the boards support. So what does it look like? Architecturally, it's pretty straightforward. We have a server that encompasses several extensions, like the dashboard, which is where we store our test results, scheduler, and we also have some of the working groups that are creating views to show results that are relevant to them. We have the dispatcher, which is the piece that actually takes care of deploying the image to the board and kicking off the tests. And we have the actual test runners. The hardware components are pretty run-of-the-mill. You've all probably got them in your own test environments. Those are some pictures of a couple of our racks. We tend to try to stack them pretty densely, but what we're finding out as we go forward is the more bits and pieces that we try to add on to them, the less we're able to do things like this. The basic components, as I mentioned earlier, server, dashboard, scheduler, dispatcher. I'll talk briefly about those to try to keep the time short. The scheduler itself is one of the relatively new pieces, and it's a piece that actually lets us submit jobs in JSON to let it know what we want to run and what kind of board we want it to run it on, and then it picks a board that's not in use and it runs the job. It also does health checks of all the boards. So once a day or every time the board comes online after being offline, it runs a static job that we know should always pass, and if it experiences a problem, then we know there might be something wrong with that board, or they all boot off of SD cards, which are prone to failure as well. So it'll keep the board offline and prevent it from running future jobs if it detects any problem with it. It also supports things like streaming the output live. If you use Jenkins, it's very similar to that feature. The dispatcher, as I mentioned earlier, it deploys the images to the boards. It goes through a series of actions that are specified in a JSON job, and does things like installing the tests and running the tests. The actions can be parameterized. And it can be actually used as a standalone piece. So if you don't want to install the entire infrastructure, but you still want to do things like board deployment and testing, it can handle all of that. We have two separate pieces right now. We're thinking of kind of consolidating this that actually handle the test runner pieces. The reason we kind of made that separate pieces right now is that the original Lava test that actually runs the tests runs on the system under test, whereas with Android, we really needed it to run over ADB. So we had to kind of write a separate tool to meet that need for now, but we're actually thinking of kind of consolidating this on one tool that does everything remotely. The server is kind of the core of it all, so it's where all of the web extensions plug into, and things like the dashboard and the scheduler are actually plugins, and basically the plugin is just a Django app that plugs into the Django project, which is Lava Server. So they can be written as just Python modules that you install on your system. And you can do things like creating new views or even adding additional APIs via the plugins very easily. We've even got examples of how to do things like that in the source. Installing it is pretty straightforward. We've got a helper script called Lava Deployment Tool that allows us to not only install production environments, but as well as development environments, and you can even install multiple instances on the same machine using Python virtual env. We release everything on PyPy, and it uses that to basically download a copy of everything it's going to need and then deploy it. We support backup and restore of your data, so if you want to take your test data out of one system and restore it into another, or out of your production system and restore it into a test system, you can do that. And it handles the upgrades and things like that as well. So this is just some eye candy I made a while back. I did a quick Gorsh demo of basically all of the jobs that we've run through Lava. So since we brought the scheduler online in, I guess, June or July of last year, we've run about 18,000 jobs through the system. And the different branches you see are different board types. And you probably can't see it. It's a little too fuzzy and far away, but this is just two of them. But as it goes forward, you'll see kind of more branches start to form as we add different ARM development board types like the Origin boards and the Snowball boards and even vExpress that we support now. And the individual nodes at the end of the branches are the individual jobs as they're getting executed, and the users flying around are the users that actually submitted the jobs. So I won't let you sit there and watch this whole thing, but if you're really interested in it, it's on YouTube, and I can provide you with the scripts that I use to generate it and everything. So if you're interested in learning more about it, and I encourage you to do so, because we're always anxious for more people to get involved in the development of it. We have documentation on readthedocs.org, which is grossly lacking, as most documentation projects are, but we are adding to it actively. The source, that's probably the main thing you'd be interested in, is all under a project group called Lava on launchpad.net. And of course, we're on IRC. We tend to hang out in #Linaro or also #Linaro-Lava now, which I forgot to put there. Anyway, that's about it. Thank you.
Okay, hello. My name is Martin Mrazik, and I work for Canonical in the product strategy department, and I would like to talk about what we do in terms of Launchpad and Jenkins integration in our test environment. So let me first state the problem. You as a developer are usually writing your code, writing your unit tests, and before creating a merge proposal, you are usually running something like make check. The issue with this is that you usually don't have the whole test environment. Your make check is running on your AMD64 box, but not running on, let's say, ARM. You are running on Precise, but not on ARIC with a different toolchain. So there is Jenkins, which is solving this issue. Jenkins provides a build isolation, provides some reasonable way how to tackle the multi-configuration problem in some reasonable way. But if you create a merge proposal, it usually takes some time until your code is in trunk, because there is somebody on the other side of the world who needs to review the code manually, click on approve, merge it to trunk, and so on. So it might take quite some time until all the tests are running on all those configurations. At the same time, doing code reviews is a good thing, and getting a fast feedback is a good thing as well. So that's the problem we were trying to solve. And right now we have a Jenkins Launchpad plugin sort of a prototype that is watching for new merge proposals in Launchpad, and as soon as a new merge proposal exists, it starts all the jobs in Jenkins on all the configurations that are interesting for your project, and as soon as those tests finish, Jenkins goes back to Launchpad, and we have a special Jenkins user that is essentially voting on the merge proposal, and it votes approve if all the unit tests are passing, or disapprove if there were some tests which are failing. So there are at least two benefits of this approach. You as a developer get almost instant feedback on how you are doing in terms of unit testing, and also helps the code reviewer, because the code reviewer then can just look in the voting section, and if the Jenkins has voted approve, he knows all the unit tests are passing and your code is probably fine. If there is disapprove, the code reviewer can simply just push back and ask the developer to fix the code before the final approve. The code is currently not public. It's a prototype. I certainly plan to blog about it on our PS quality blog, qualityr.wordpress.com. I hope in the next week or so I will be there together with some how to integrate this in your Jenkins environment. And that's it.
All right, so I'll be talking about the Phoronix Test Suite and openbenchmarking.org. Since most of you are probably already familiar with the Phoronix Test Suite and openbenchmarking.org, feel free to interrupt me at any point, and I'll gladly talk about anything you want to say or any questions, feedback, whatever. So the Phoronix Test Suite, for those that don't know, is an open source benchmarking framework that works not only on Ubuntu, but most other Linux distributions, BSD, Solaris, Mac, Windows, even Minix and Herd. Everything's very extensible. You can easily add in any new test profiles that you want. It's very trivial. It's basically a set of bash scripts and XML files. And from there, they're basically published to openbenchmarking.org, which is a centralized repository for storing test profiles, test suites, and the test results, so they're very collaborative. You can basically be like, hey, I uploaded this result file, come run this file, and then from there it'll automatically fetch a relevant test profile, the relevant test suite if needed, and then all that other data, and then compare side by side in a very intuitive manner. So let's see what's new here. And if the network's still up. So this is a test result by someone if, oh shit. And the only reason I'm running Mac OS X, by the way, is that I actually get better battery life virtualizing Ubuntu on top of Mac than running bare metal. So from here anyways, we basically see all of the parse system hardware and software in a very easy to use manner. The Phoronix Test Suite has a library called FODEVI that takes care of automatically parsing all this, and if it sees, hey, for your system manufacturer, you're exposing OEM or some other bullshit like some of the tier 3 vendors and tier 2 vendors do, it tries to attempt to read from other information that's exposed. And then, yeah, basically that's a fallback to ensure that everything's cleanly parsed. And we happen to see a wide variety of tests. The Phoronix Test Suite can basically support anything from quantitative benchmarking to image quality comparisons to pass-fail scenarios. But yeah, obviously for the Phoronix.com, things were mostly quantitative focused. And so we see a whole variety of tests that are being run. Looks to be a lot of graphics tests. Lots of results here, and then actually. All right, here's an actual comparison being done by someone. No idea, I just found it on the front page. And so basically anything, it's very focused upon being easily reproducible and allowing for side-by-side comparisons. The Phoronix Test Suite can also do things like monitoring the CPU temperature and power consumption simultaneously for providing performance per watt, or basically any other system vital that's pretty relevant, even like power consumption on the 12-volt rail or anything. And that's basically about it. If anyone has any questions, you can find me around UDS all week, and thanks.
Okay, so hi, I'm Daniel, and I work in the hardware certification team at Canonical. And, and as you can imagine, in hardware certification, we have to do a lot of incredibly crazy testing that involves inserting and removing a USB stick hundreds of times, or doing the same with memory cards, plugging in and out external monitors, which is what we have been doing here pretty much all evening. What's the problem with that? Basically, that it's manual work, and well, we don't like manual labor, right? It's something that we prefer to avoid because it's error-prone, it consumes human resources, and it doesn't scale. But the problem with these kinds of tests is how do you automate them? It's not like immediately obvious how to automate them. So we have been looking at solutions for working on automating this. And as you can see from the beginning of the presentation, what we came up with. First, these are tests that are traditional manual, like inserting and removing storage units, memory cards, external screens, external drives, headphones or microphones, pressing the power button, something that incredibly it's really hard to automate, or opening and closing the lid. So yeah, how do we automate them? On an abstract level, what we have to do is get an appropriate actuator, something that actually does the action, and then come up with a way of driving it somehow when we want it to insert or remove the device or close the lid or whatever. So how can we actuate like the table I presented before? Some of them can be actuated by relays, by just closing or opening an electrical contact. These are memory cards, external screens, external drives. Microphones and headphones are not that obvious because there's an actual mechanical switch that detects insertion, so that one is not so obvious. So that's why it has a question mark. You can press the power button using a solenoid, or you can use a servo to open and close the lid. These are some of the possibilities, really. So what we have been looking into is the low-hanging fruit, which is using relays, which is probably the easiest way to interact with these components. And we use an Arduino board to control them, as you saw at the beginning of the presentation. The advantages are that the Arduino is really cheap. It's easy to program, well, yeah, it's easy to program. Control circuitry can be neatly packaged in a shield that mounts on top of the Arduino, and you have a neatly stacked tower of integrated circuits instead of a huge board that is very unwieldy and difficult to install. And shields can be stacked one on top of each other, so potentially one Arduino board can drive many actuators. So what we decided to do is automate USB plugging and unplugging as a proof of concept. The advantage with USB is that it's really easy to simulate insertion and removal because there's just one power rail that you can disconnect, and then the system will think that someone unplugged the USB unit, and that's like really easy to work with. Okay, my diagram doesn't look so good here, but basically what we did was we hooked up an Arduino to a thing that controls opening and closing of a USB cable that basically has a female connector on one end on which you plug a USB stick, and a male connector on the other end, which you plug into the PC port. And the PC itself sends the signal to the Arduino to connect or disconnect the USB memory stick. You can see a chicken and egg problem here. I mean, I'm testing USB and I'm controlling that through USB, so that doesn't jive too well. But it's just a proof of concept. I mean, the idea is if the technique works, that we can potentially switch basically anything we want. And the one other thing is that the USB ports are quite reliable. I don't think we have a single system in certification that has failing USB ports. Well, actually, we have one, but well, that's beside the point. It's usually pretty reliable, right? So if we can't switch any of the peripherals, we can assume that USB is not working. So in that respect, it was like the easiest thing to do. So on the software side, what did we do? Basically, on the Arduino, you load a small program that receives 1-byte commands. It can be more complex than this, but that was the easiest way to do it. And then activates the actuator based on what I send, and returns a confirmation string just so I know that the Arduino didn't die in the process. And on the PC, we have a Python module that does communications with the Arduino, and a small Python program that actually tells the Arduino, OK, so now insert the device, remove it, stuff like that. The thing is that all the communication is via serial port on a TTY, so it can potentially be you don't necessarily have to use Python. You can use any other language. You can even use STTY to set the COM parameters and use echo to send stuff to the Arduino. It's like as language agnostic as they get. So we built a hardware prototype. We hooked it up to a test that's run by Checkbox. So in that respect, Checkbox is our test running framework. So yeah, it runs the test, asks the Arduino to plug in the device, runs a series of tests on the actual device, unplugs it, and yay, success. And it works. The problem we kind of have here is that it was very last minute preparing this, so I don't have like an actual picture of the device or a demo, a live demo, which we like to do because it goes click, click, and it's very exciting. But I can tell you that it works. I mean, the proof of concept worked very well, and that's encouraging because then we can go to the next steps, which are actually the plan we have is finish designing and fabricating, so to speak, the prototype shield, of which I have a diagram right here. This is a circuit board that was designed with Eagle CAD for electronic design. And making sure that the shield actually works and is solid and reliable. And after that, the next thing we want to try is automating SD card testing, which is cumbersome to test manually, so it's something that we'd really like to avoid testing by hand. And next, we can potentially look into controlling Steve Conklin's BGA switcher that Mark was pimping the other day with the Arduino, basically. Because, I mean, once we have the actuators, as I said, basically the Arduino can drive all that formerly manual interaction. And if the technique proves useful, we can maybe mass produce that so that we can have one board hooked up to each system that we have to test. And then I'll be out of work, which is basically very interesting. So, well, that's it. Thanks. If you're interested in this technique and how we're doing it, let me know. Cool. You? Sure. A standard USB relay board? OK, well, if the thing is, with the Arduino, we have the possibility of potentially driving stuff that needs a bit more intelligence than that. For instance, we could potentially have a solenoid driving the power button, and the Arduino can work independently of the PC and power it off, and then wait a set amount of time, power it back on. So if you want more intelligent behavior, it makes sense to have something a bit smarter, which is the Arduino. And the capacity is limited, so you can't do really fancy stuff, but it's a starting point. One interesting potential application is that you can have the Arduino actually simulate the USB input-output protocol. So I can test USB mice and keyboards by actually sending keys on the Arduino and making sure that the PC receives exactly that key. So it makes sense to have something a bit more intelligent, especially if it's as dirt cheap as the Arduino at about, I don't know, $20 a board, perhaps. Cool. Thanks.
Hello. My name is James Westby. I work on some things. But today, I am not going to do a demo. So I'd like to talk to you today about testing and monitoring. So I'm going to define testing as assurance that the software will keep working as it changes. You write your unit tests so that you can, in future, make changes, and the software will keep working as you expect it to. And monitoring is assurance that the software is working right now as it is in use. All your tests are no good if the software is currently failing for somebody. You can write all the tests in the world, but if you're not actually providing the service that you're supposed to be providing, then it's of no good. So monitoring is complementary to testing in that it can tell you that right now you are providing the service that you are supposed to be providing. And this is very important if you actually want to satisfy your customers, your users. So there are similarities as well between testing and monitoring. For both, automation is good. You don't want to do a lot of manual testing on every single commit. And you don't want to have someone sat there all day purchasing software or making orders or whatever it is your system is supposed to be doing. Automation to tell you that it's doing the right thing would be very useful. But automation isn't everything. You still need people. They both save you from embarrassment. This is something I value quite a lot, but it sometimes goes wrong. So there are a lot of similarities between testing and monitoring. So many, in fact, that I think monitoring should probably be considered another form of testing, alongside unit testing, integration testing, etc. And we should treat it in much the same way that we now treat testing in software development. So write tests for your software. It helps you write better software and helps you continue to improve your software without getting bogged down in regressions. So please write tests. And write monitoring checks for your system as well, please. So I'm not going to tell you what a good monitoring check is. You need to think about the system that you're building, and you need to decide what you can check to make sure the system is functioning as expected. So I work on Software Center and the server side of that, and so we were talking today about how we should have monitoring that when someone starts the purchase of a piece of software, they actually are able to complete the purchase of the piece of software unless they cancel out of it. And if someone is unable to complete the purchase of the software, I want to know straight away so that I can fix the problem and make sure that we're able to continue keep selling the software. So you need to consider your system and think of all the places that you want to have monitoring. And when you sit down and think about it, you're probably going to find that you have hundreds of different things you want to monitor for any system of any sort of complexity. And that may seem daunting at first, but when you think about it, you feel wrong for not having done it already. So don't worry about the scale of these things, and start somewhere and start adding these checks. But I think there's also a deeper symbiosis between monitoring and testing than what I've described already, especially when they're done well, and you should be trying to do things well. So firstly, monitoring points to a set of tests that you should run against the software in development. If there's something you are monitoring in the live system, you should have a test or a set of tests which test that works in development as well. Otherwise, you're not going to have the assurance when you release a new version that it's going to continue working. Your monitoring checks will tell you that it stopped working, but you would have liked to have known before. So when you add a monitoring check, consider what tests you should have to provide that same assurance within the development environment. And maybe even consider running the monitoring checks themselves as a test against the software. What I'm going to find is passive monitoring will catch problems as you encounter them. So this is what I was talking about a minute ago. When a user starts a purchase, I want to ensure that they complete the purchase unless they cancel. So this is what I consider to be passive monitoring. We're just watching what's going on in the system, and we alert when we see a problem. Whereas active monitoring will catch the problems before the users encounter them. In this case, we would have a bot which would just sit there, and every 5 minutes, it would try and purchase a piece of software using some mechanism built into the software, which hopefully didn't mean that anyone could buy any software without spending any money, but we'll ignore that for a moment. So this will tell you about the problem before a user gets to it, you hope, because if you do it frequently enough, there are going to be very few users who would do something in between the gap in the monitoring. So this is like the next level of monitoring, which will tell you about problems before anyone is affected by them, which would be great to know every time something went wrong, because your users would never know any different. But my assertion is that this active monitoring requires testable software, where testable software is defined as software which is incredibly easy to write automated tests for. A lot of software today is not fully testable. So testability has a lot of parallels with isolation and being able to run without having any side effects. So when you're designing a piece of software, if you're writing unit tests first, then often you will end up with testable software. And this will enable you to write better monitoring checks as well. So you get better tests and you get better monitoring. So do it. So write your tests as you write your software. I believe in test first, and I think you should too. And write monitoring checks as you write your software. So at the very least, you should be thinking about the monitoring checks as you write the software. You can change the way you build the system to enable you to monitor things you want to monitor. But you can go even further and write the monitoring checks themselves as you're writing the code under consideration. Don't bolt on the monitoring checks at the end. Just write them when you decide what you want to do, and make sure the system is able to be monitored in the way that you think is appropriate. And if you're doing all that while you're developing, as soon as your users get hold of it, you're going to know about problems immediately. So monitoring is a form of testing and should be a priority when writing your code. Otherwise, you're going to have an unmonitorable system, and you're going to continually disappoint your users. So please consider monitoring, and please consider it a form of testing. Thank you.